Hello guys, welcome back to my channel. Today in this session we are going to see a research paper which comes under deep learning. It is titled as Machine Learning and Deep Learning. So it is a comparative study and the author are Ayushi Chahal and Preeti Gulia. So it is published in a journal volume 8 issue 12. So coming to the introduction, as it is a comparative study, so first artificial intelligence. So coming to the AI, so AI it aims to provide computers with a human-like intelligence, allowing them to perform tasks such as reasoning, problem solving, and decision making. And coming to the machine learning, it is a subset of artificial intelligence. So machine learning it enables the systems to learn from data and improve their performance over time without being explicitly programmed. It focuses on developing algorithms that can identify patterns and make predictions. So the next is deep learning. It is an advanced form of machine learning. So the deep learning it uses artificial neural networks with multiple layers to learn from large amounts of data, enabling the higher accuracy of data and in a complex tasks like image and speech recognition. So the machine learning procedures, it involves few steps. So first is feature extraction. Here it identify and extract the relevant features from the raw data that will be used as input for the model, and this step it helps in simplifying the data and focusing on key aspects that influence the predictions. So the next is select a corresponding ML algorithm. Here choose an appropriate algorithm based on the nature of the problem, data type and the desired outcome. So the examples include decision trees, support vector machines and neural networks. And the next is train and evaluate the data models. So here use training data to build the model and then evaluate its performance using metrics like accuracy, precision and recall. So these process may involve tuning hyperparameters to optimize the model. The last is use trained models for the prediction. So once the model is trained and evaluated, so it is used to make predictions or on new or unseen data, enabling the real world application and insights. So requirements for the good machine learning systems. First is data preparation capabilities. So here effective machine learning system requires robust data pre-processing including cleaning, normalization and feature engineering which ensure the quality and relevance of the data being used. Next is advanced algorithms. So example is regression decision trees. So here the system should support a range of advanced algorithms like regression decision trees, support vector machines and neural networks to tackle different types of problems and data structures. And next is scalability for large data sets. Here a good machine learning system, it must be able to handle and process large data sets efficiently, ensuring that the system they can scale up as the amount of data grows without a significant loss in performance. And next is ensemble modeling and automation. So here the ability to use ensemble methods, for example bagging, boosting and automation tools like AutoML, it helps to improve model accuracy and it reduces the manual effort also and making the system more efficient and effective. So the machine learning approaches, the first is shallow learning. So it involves models with a single layer or few layers such as support vector machines, decision trees and linear regression. So these models are suitable for simpler tasks where feature extraction and problem complexity are not too high. Coming to the deep learning, here it uses multi-layer neural networks including several hidden layers to model complex patterns in data. So the deep learning, it is particularly effective for tasks like image recognition, natural language processing, and complex pattern recognition, where the large data sets are available. So next is supervised and unsupervised learning. So coming to the supervised learning, it requires labeled data, like the model is trained using labeled data sets where each input comes with a corresponding output or label, and predicts based on historical data, like it learns from the labeled data, and then it uses these training to predict the outcomes for new unseen data. And for example, classification like spam detection, and regression predicting house prices. So coming to the unsupervised learning, here it works with the unlabeled data, like the model works without labeled output, and it tries to identify the underlying patterns or structures in the data, and it finds the hidden patterns, like it explores the data to discover relationships like clusters or associations among the data points. For example, like in the clustering we can take as customer segmentation, and association is market basket analysis. So the deep learning architectures in the generative models, it include DBN, which stands for Deep Belief Networks. So it learns the data distribution to generate new samples. And coming to the autoencoders, where it compresses the data into lower dimensions and it reconstructed it for feature learning. And coming to the discriminative models, where it involves CNN and DSN. So CNN, it stands for convolutional neural networks. It is specialized for image data and recognizing the patterns through convolutional layers. So the DSN is deeply supervised networks, where it incorporates the supervision at multiple layers for improved learning efficiency. And the next is hybrid models, where it combines the generative and discriminative approaches, such as generative adversarial networks like GANs, which use a generator and a discriminator to enhance the generation. Application of machine learning and deep learning. The first is healthcare, where it diagnoses like assisting in disease diagnosis through image analysis, and wearable devices like monitoring health data from wearables. And finance, where fraud detection, like identifying fraudulent activities in transactions. And risk assessment, where evaluating credit risk using predictive models. And transportation, where route optimization, finding efficient travel routes. And predictive analysis, like forecasting the traffic patterns for better planning. And coming to the conclusion, here the machine learning and the deep learning are crucial for enhancing system intelligence, while the deep learning, it excels with large data sets, and the machine learning is more effective for smaller data sets. So the researchers must carefully choose the appropriate approach based on the data set characteristics and the specific problem they are addressing. Thank you guys for watching.